Use RESTCONF to access an iOS XE device. The RESTCONF protocol provides a simplified subset of netconf features over a RESTful API. RESTCONF allows you to make RESTful API calls to an iOS XE device. The data that is returned by the API can be formatted in either XML or JSON. In the first half of this lab, you will use the Postman program to construct and send API requests to the RESTCONF service that is running on the CSR1KB. In the second half of the lab, you will create a Python scripts to perform the same tasks as your Postman program. Required resources: one PC with operating system of your choice, VirtualBox or VMware, DevNet Associate Virtual Machine, CSR1KB Virtual Machine. Launch the virtual machines and verify connectivity. In this part, you launch the two virtual machines for course and verify connectivity. You will then establish a secure shell SSH connection. Launch the virtual machines. If you have not already completed the lab, install the virtual machine lab environment. And the lab, install the CSR1KB virtual machine. Do so now. If you have already completed these labs, launch both the DevNet Associate Virtual Machine and CSR1000B Virtual Machine now. Okay, go to VirtualBox. First, I will start the DevNet Associate Virtual Machine. Verify settings. Network, in my case, use NAT, and cable is connected. Okay, and start. Ready. And now the router. Okay, go to developer Cisco.com. Login. You can use Google to log in. Okay, and DevNet resources, sandbox. Get started with sandbox. And on sandbox labs, you can use regular. For example, iOS XE on CSR and latest code to reserve version 16.11 or iOS XE on CSR latest code 17.3.1 to reserve, or this another iOS XE on CSR recommended code 16.9.3 to reserve. Okay, I will use always on. This iOS XE on CSR version 17.3.1 latest code, or iOS XE on CSR recommended version 16.9.3. Okay. I will use 17.3.1 always on and click here. So this is the device already started on the cloud, version 17.3.1. Access details, the host, the name, the SSH port, netconf port, RESTCONF port 443 using HTTPS, username, developer, and password. C uppercase 1, SEO 1, 2, 3, 4, 5. Verify connectivity between the virtual machines. In the CSR1KB virtual machine, press enter to get a command prompt, and then use show IP interface brief to verify that the IPv4 address is 192.168.56.101. If the address is different, make a note of it. Okay, in this case, it's not using an IP address, it's using a name. So this is the name, sandbox-iosxe-latest-1 cisco.com. Open terminal and DevNet associate virtual machine. This is the terminal, open the terminal. Ping the CSR1KB to verify connectivity. You should have already done this in the installation labs. If you are not able to ping, then revisit those labs. Okay, from the DevNet associate virtual machine, ping to the IP address of the device. In my case, the device is on the cloud. Ping 5 pings, count 5. And use this name, sandbox-iosxe latest-1. Sandbox-iosxe latest-1.cisco.com. Enter. Okay, this is the translation. This is the specific IPv4 address of the device. But ping is not working. Control C to stop this process. 5 packets transmitted, 0 received, 100% packet loss. That means this router is not allowing the ping tests for security and for availability. And don't worry about this. Verify SSH connectivity to the CSR1KB virtual machine. In the terminal of the DevNet associate virtual machine, SSH to the CSR1KB virtual machine. Okay, use SSH protocol, the username, and the IP address. Okay, SSH protocol, the username is different. In my case, is developer. Okay, repeat the previous command and modify. SSH developer, the user, and the username, and it's not an IP address, this is the name. Okay, enter. And password. Use this password. C uppercase 1 SEO 1 2 3 4 5. C uppercase 1 SEO 1 2 3 4 5. Enter. Okay, very nice. This is the host name. And leave the SSH session open for the next part. Do not do this for now. Configure an iOS-XE device for RESTCONF access. You will configure the CSR1KB virtual machine to accept RESTCONF messages You will also start the HTTPS service. The services discussed in this part may already be running on your virtual machine. However, make sure you know the commands to view the running services and to enable them. Verify that the RESTCONF daemons are running. RESTCONF should already be running because it was part of the default configuration provided by NetACAT. From the terminal, you can use the Show Platform Software Yang Management Process command to see if all the daemons associated with the RESTCONF service are running. The netconf daemon may also be running, but it won't be used in this lab. If one or more of the required daemons are not running, proceed to step 2. Okay, use this command, show platform software Yang management process. Enter. Okay, you are on the router and show platform software Yang management process. Okay, all is running. Confd, NESD, sign, NCSSHD, DMI authentication daemon, and Jinx. This is the web server, ndbmand, pubd. Enable and verify the RESTCONF service. Enter the global configuration command RESTCONF to enable RESTCONF service on the CSR1 KB. Okay, configure terminal and RESTCONF. Configure terminal RESTCONF. Very good. Verify that the required RESTCONF daemons are now running. Recall that NCSSHD is the netconf service, which may be running on your device. We do not need it for this lab. However, you do need Nginx, which is the HTTPS server. This will allow you to make REST API calls to the RESTCONF service. Okay, exit and on privilege exec mode, show platform software Yang management process. Exit. Okay, privilege exec mode, up arrow to repeat show platform software Yang management process and enter. Okay, Nginx is running. Enable and verify HTTPS service. Enter the following global configuration commands to enable the HTTPS server and specify that the server authentication should use the local database. Okay, configure terminal, enable the secure server, and enable the local authentication. Configure terminal, IP HTTP secure-server, enter, and IP HTTP authentication local. Very nice. Verify that the HTTPS server Nginx is now running. Okay, the same command. Exit. Repeat show platform software Yang management process. Nginx is running. Open and configure Postman. You will open Postman, disable SSL certificates and explore the user interface. Open Postman. In the DevNet Associate Virtual Machine, open Postman application. Okay, on menu, applications all, at the end, or you can search Postman. If this is the first time you have opened Postman, it may ask you to create an account or sign in. At the bottom of the window, you can also click the skip message to skip signing in. Signing in is not required to use this application. Disable SSL certification verification. Postman has SSL certification verification turned on. You will not be using SSL certificates with the CSR1KB. Therefore, you need to turn off this feature. File Settings, General tab, SSL certificate verification off. Close Settings. Okay, File Settings, General, and SSL certification verification set to off. Close. Use Postman to send GET requests. You will use Postman to send GET requests to the CSR1KB to verify that you can connect to the RESTCONF service. Explore the Postman user interface. In the center, you will see the Launchpad. You can explore this area if you wish. Click the plus sign next to the Launchpad tab to open a GET untitled request. This interface is where you will do all of your work in this lab. Okay, this is the Launchpad. Okay, in the center, you can click here on plus sign, and you can select a method. I will use GET. Enter the URL for the CSR1KB. The request type is already set to GET. Leave the request type set to GET. In the Enter Request URL field, type the URL that will be used to access the RESTCONF service that is running on the CSR1KB. https:// the IP address and RESTCONF. Okay, choose GET, the URL https://. Remember, I'm not using IP address, I'm using a name, this name. Copy and use RESTCONF. Okay, and enter authentication credentials. Under the URL field, there are tabs listed for params, authorization, headers, body, pre-request script, test, and settings. In this lab, you will use authorization, headers, and body. click Authorization tab. Under Type, click the down arrow next to Inherit Authorization from Parent and choose Basic Authorization. Okay, go to Authorization, Inherit Authorization from Parent. Okay, and change from Inherit Authentication from Parents to Basic Authentication, this Basic. So now you can see username and password and enter. Remember, my username is developer and password is this. Username developer, password C1SCO12345. Okay. Click headers, then click the 7 hidden. You can verify that the authorization key has a basic value that will be used to authenticate the request when it is sent to the CSR1KB. Okay, header 7. 7 hidden. The authorization is basic. The host and other settings. Set JSON as the data type to send to and receive from the CSR1KB. You can send and receive data from the CSR1KB in XML or JSON format. For this lab, you will use JSON. In the headers area, click in the first blank key field and type connect type for the type of the key. In the value field, type application Yang data plus JSON. Okay. On key field, type content type. Case sensitive on key field, content this content type. In the value field, type application Yang data plus JSON. Here on value, type application Yang data application slash Yang dash data plus JSON. Very good. And this tells Postman to send JSON data to the CSR1KB. Below your content type key, add another key value pair. The key field is accept and the value field is application Yang data plus JSON. Okay, and down here, accept. This is the key, and the value is application. Basically, it's the same, so copy and paste. Accept application Yang data plus JSON. Very nice. You can change application Yang data plus JSON to application Yang data plus XML to send and receive XML data instead of JSON data if necessary. Send the API request to the CSR1KB. Postman now has all the information it needs to send the GET request. Click Send. Below temporary headers, you should see the following JSON response from the CSR1KB. If not, verify that you completed the previous steps in this part of the lab and correctly configured RESTCONF and HTTPS service. Okay. Send. You should get this on JSON format. RESTCONF data operations Yang library version. Okay, very good. This JSON response verified that Postman can now send other REST API requests to the CSR1KB. Use a GET request to gather information for all interfaces on the CSR1KB. Now that you have a successful GET request, you can use it as a template for additional requests. At the top of Postman, next to the Launchpad tab, right-click to get tab that you used and choose Duplicate tab. Okay, up here, right-click, Duplicate tab. Now you have 2, 1, and 2. Use the second. It's already configured. Use the IETF Interfaces Yang model to gather interface information for the URL at data IETF interfaces column interfaces. Okay, but use this. HTTPS, the IP address RESTCONF data IETF-interfaces column interfaces. Okay, only add this. The protocol, the name RESTCONF, data IETF interfaces column interfaces. Click send. You should see a JSON response from the CSR1KB that is similar to the output shown below. Your output may be different depending on your particular router. Okay, this is the information about interface 1, gigabit interface 1. Okay, send. Okay, interface number gigabit Ethernet 1, description, IPv4 address, subnet mask, interface number 2, IP address, IPv6 address, and other interfaces like Loopback interfaces created by another students using this router on the cloud. Okay, very good. Use a GET request to gather information for a specific interface on the CSR1KB. Only the gigabit Ethernet 1 interface is configured, so specify use this interface. Extend the URL to only request information for this interface. Duplicate your last GET request add the interface equal parameter to specify an interface and type in the name of the interface. Okay, slash interface equal gigabit Ethernet 1. Okay, it's sensitive. Okay, duplicate this tab and add this slash interface equal gigabit Ethernet 1. Protocol name RESTCONF data IETF interfaces slash interface equal gigabit Ethernet 1 send. Okay, so you got only gigabit Ethernet 1 information. If you request interface information from a different Cisco device with names that use forward slashes, such as gigabit Ethernet 001, use the HTML code. And this %2f for the forward slashes in the interface name. So 0/0/1 becomes 0%2f, 0%2f1. Click send. You should see a JSON response from the CSR 1KB that is similar to the output below. Okay, information of gigabit 1. This interface receives addressing from a VirtualBox template. Therefore, the IPv4 address is not shown under show running config. Instead, you will see the IP address DHCP command. You can see this also in the show IP interface brief output. Show IP interface on the device. Okay, on the SSH connection. Okay, enter. Now it's disconnected by the SSH timeout. Enter, Control C. Enter. Enter, Control C. Okay, disconnected and try again. SSH, username, developer, and the name. The password C1SCO12345. Use show IP interface brief. Now you can see the IP address of gigabit Ethernet 1. In the next part, you will need to use JSON response from a manually configured interface. Open a command terminal with the CSR1KB and manually configure the gigabit Ethernet 1 interface with the same IPv4 address currently assigned to it by VirtualBox. Configure terminal, interface gigabit 1, set an IP address, and verify with show IP interface brief. So in my case, I will create a loopback. Okay, and on the router on SSH connection, create a configure terminal interface loopback. For example, number 666. Enter IP address. You can use this IP, this subnet mask. Okay, very nice. Then exit. And show IP interface brief. Okay, another exit. Privilege exit mode. Show IP interface brief. This is my IP address. My loopback interface. return to Postman and send your GET request again. You should now see IPv4 addressing information in the JSON response. In the next part, you will copy this JSON format to create a new interface. Okay, go to Postman and remember, I just created Loopback 666. So here, change Loopback 666. Okay, I will get the information about the specific interface Loopback 666. Okay, RESTCONF data IETF interfaces interfaces/interface equal Loopback 666 head. Very nice, Loopback 666, the IP address and subnet mask. Very good. Use Postman to send a PUT request. You will configure Postman to send a PUT request to the CSR1 KB to create a new loopback interface. If you created a loopback interface in another lab, either remove it now or create a new one by using a different number. Duplicate and modify the last GET request. Duplicate the last GET request. Okay, this last tab, right click, duplicate. Okay. For type of request, click the down arrow next to GET and choose PUT. Okay, PUT. Okay. For interface parameter, change it to loopback and number to specify a new interface. For example, click loopback 777. In this case, loopback 777. Okay, the name RESTCONF data IETF interfaces interface loopback 777. A different number. Configure the body of request specifying the information for the new loopback. To send a PUT request, you need to provide information for the body of request. Next to the headers tab, click body. Okay, next to headers, go to body, here, body, and click raw. The field is currently empty. If you click send now, you will get error code 400 bad requests because loopback 1 or the new loopback does not exist yet, and you did not provide enough information to create the interface. Fill the body section with the required JSON data to create a new loopback interface. You can copy the body section of previous GET request and modify it. Or you can copy the following into the body section of your PUT request. Notice that the type of interface must be set to software loopback. Okay, and add this on body. Okay, and on raw, add the following and go to the previous tab for the loopback 666 and copy this. Copy the output, the response of the router. Copy. Go to the new PUT request for loopback 777, body raw, paste. But modify this. remember these characters. Be careful, IETF interface. The name is a new loopback, will be 777. The same like this, loopback 777, loopback 777. And you can add a description. Okay, enter quotation marks, description, column, space, quotation marks, the value, new loop, for example, and comma. Don't forget comma, and type IANA if type software loopback. This is very good. Case sensitive. Enable true. IETF IPv4, very good. Address. Change the IP. I will use a different IP address. 777. With this net mask, or use any net mask. IETF IPv6, nothing, and ends with this character. Okay. Okay. Should look like this. Very nice. Send. Click send to send the put request to the CSR1KB. Below the body section, you should see the HTTP response code status 201 created. This indicates that the resource was created successfully. Okay, send. And look at the output. Status 201 created. Very good. You can verify that the interface was created. Return to your SSH session with the CSR1KB and enter show IP interface brief. You can also run the Postman tab that contains the request to get information about the interfaces on the CSR1KB that was created in the previous part of this lab. Okay, and you can go to the SSH connection. Okay, enter. Okay, now it's disconnected by the SSH timeout. Enter, enter, enter. Control C, Control C, Control C. Enter, enter, Control C. Okay, and access again, SSH, developer, the router's name, enter. The password C1SCO12345. Show IP interface brief. Now, my new interface created by a RESTCONF put request. The number, the IP. The method is not manual, is other RESTCONF method. And also on Postman, go back to the previous tab, the previous get get request and change this to Loopback 777 to get information about this specific interface, Loopback 777. Get is already configured and set. And now you will see the JSON format with the JSON output with Loopback 777, the IP and subnet mask. Very, very good. Use a Python script to send GET requests. You will create a Python script to send GET requests to the CSR1 KB. Create the RESTCONF directory and start the script. Open Visual Studio Code. Then click File, Open Folder, and navigate to DevNet source directory. Click OK. Okay, Visual Studio Code. Go to File, Open Folder. And down here, this on Labs DevNet source and open. And you will see the DevNet source directory in the Explorer here. DevNet source directory. Open a terminal window in Visual Studio Code, terminal, new terminal. Okay, terminal, new terminal. Okay, and you will see the terminal in the DevNet source directory. Create a subdirectory called RESTCONF in the DevNet source directory. In DevNet source directory, make directory RESTCONF. Enter. In the Explorer pane under DevNet source, right-click the RESTCONF directory and choose New File. Okay, on DevNet source directory, go to RESTCONF. This is right-click and New File. Name the file RESTCONF get.py. RESTCONF-get.py is a Python file. Be careful, RESTCONF-get.py. Enter. Now the file is empty, but the file is in the RESTCONF subdirectory. Enter the following commands to import the modules that are required and disable SSL certificate warnings. Okay, add these three libraries or import these modules. Import JSON, import requests point packages point URL lib3 disable underscore warnings and these characters. Enter. The JSON module includes methods to convert JSON data to Python objects and vice versa. The requests module has methods that will let you send REST requests to a URL. Create the variables that will be the components of the requests. Create a variable named API URL and assign the URL that will access the interface information on the CSR1 KB. Okay, this is the API URL. And you can use the Postman. This you can copy this. Enter, and the variable is API underscore URL space equal quotation marks and paste. But it should be only interfaces. The protocol HTTPS, the name of the device or IP address, RESTCONF, data, IETF interfaces, column interfaces. Okay, enter. Create a dictionary variable named headers that has keys for the accept and content type and assign the keys the value application gen data plus JSON. Okay, add the headers. So dictionary headers accept you can use Postman to copy this here on headers at the end. You can copy this. Application gen data plus JSON, comma, and another variable with is content type dash type case sensitive. The same value application gen data plus JSON. Okay. Be careful with alignment and indentation. Don't forget comma here. Create a Python tuple variable named basic authentication that has two keys needed for authentication, username and password. Okay, use this. Enter. Backspace. Basic out space equal space. Remember username, developer, and password. In my case, it's different. Developer. Password. C uppercase 1 SC O 1 2 3 4 5. Enter. Create a variable to send the request and store the JSON response. Use the variables that were created in the previous step as parameters for the request get method. This method sends an HTTP GET request to the RESTCONF API on the CSR1 KB. Assign the results of the request to a variable named resp for response. That variable will hold the JSON response from the API if the request is successful. The JSON will contain the returning yang data model. Enter the following statement: resp and the variables. Resp requests that get the first variable API URL, copy, paste, comma, space, the authentication is equal to this value, the basic authentication. Comma space, the headers equal to headers, this, comma space, verify false. Enter. Okay, be careful. The URL, the authentication, the headers, and verify false. The table below lists the various elements of this statement. Resp, the variable to hold the response from the API. Request get, the method that actually makes a GET request. API URL, the variable that holds the URL address string. Auth, the tuple variable created to hold on the authentication information, username and password. The headers, a parameter that is assigned the headers variable. Verify false disables verification of the SSL certificate when the request is made. To see the HTTP response code, add a print statement. Okay, print the response. Okay, enter print resp. Okay, this print this. Save and run your script. You should get the output shown below. If not, verify all previous steps in this part, as well as the SSH and RESTCONF configuration for the CSR1 KB. Okay, the response should be 200. But first navigate to RESTCONF subdirectory and run the Python file. Okay, don't forget to save file, save, navigate to RESTCONF cd, change directory. Once you are on RESTCONF, Python 3, and the name of the file is rest. Press tab to complete. RESTCONF get py, enter. Response 200. Okay, very nice. Success. Format and display the JSON data received from the CSR1 KB. Now you can extract the yang model response values from the response JSON. The response JSON is not compatible with Python dictionary and list objects, so it must be converted to Python format. Create a new variable called response JSON and assign the variable resp to it. add the JSON method to convert the JSON. The statement is as follows. Okay, use this. Okay, enter and response underscore JSON equal to response that JSON. Okay, JSON format assigned to response underscore JSON. Add a print statement to display the JSON data. Okay, a print statement. Copy and paste with print this variable response underscore JSON. Okay, review your codes. The code should look like this. Don't forget to save. Save and run your script. And this should be the output. Save, repeat the previous command, Python 3 RESTCONF get, enter. Okay, this is the output. Remember the interfaces information about all interfaces. So this is gigabit 1, description, IP address, gigabit 2, description, IP address, gigabit 3, loopback interfaces. This is loopback 666, loopback 777. Very good. To prettify the output, edit your print statement to use the JSON dumps function with the indent parameter. Okay, and here in the last print add JSON that dumps. Comma space indent equal 4. Okay, JSON dumps response JSON indent 4. Save. Save and run your script. Okay, yes. This output is virtually identical to the output of your first Postman GET request. Okay, save and run. Python 3 RESTCONF, yeah. Enter. Okay, very nice. Pretty JSON format. Gigabit 1, IP address. Loopback 666 IP address. Use Python script to send a PUT request. You will create a Python script to send a PUT request to the CSR1KB. As was done in Postman, you will create a new loopback interface. Import modules and disable SSL warnings. In the Explorer pane under DevNet source, right-click the RESTCONF directory and choose new file. Name the file RESTCONF put. Okay, and DevNet source, go to RESTCONF and right-click new file. The name should be restconf-put.py. And be careful, restconf-put.py. Enter. The file is empty, and enter the following commands to import the modules and disable SSL certificate warnings. Okay, the same as the previous file. Okay, go to get file and copy this. It is the same. Go to put, paste. Okay, enter. And create the variables that will be the components of the request. Create a variable named API URL and assign it the URL that targets a new Loopback 2 interface. Okay, this variable specification should be on one line in your script. Okay, copy from the get file, copy this and put on put file, enter and paste. Okay, but specify a new interface. Specify slash new interface equal L uppercase loopback, for example 888, a new loopback. Okay, look at this API URL variable, protocol name or IP address, RESTCONF data, IETF interfaces, slash interface equal loopback 888, and you will create a new loopback. Enter. Create a dictionary variable named headers that has keys for accept and content type, and assign the keys the value application length data plus JSON. The same as previous. Okay, go to get file and copy headers, paste, accept application length data plus JSON, content type application length data plus JSON. Enter. Backspace, backspace, backspace. Create a Python tuple variable named basic authentication that has two values needed for authentication, username and password. Okay, go to the previous file and copy the same. Paste, be careful, basic authentication, developer and C1 SEO 1 2 3 4 5. Enter. Create a Python dictionary variable length-config that will hold the length data that is required to create the new interface loopback 2. In my case, is loopback 888. You can use the same dictionary that you used previously in Postman. However, change the interface number and address. Also be aware that Boolean values must be capitalized in Python. Therefore, make sure that the T is capitalized in the key value pair for enable true. Okay, you can use this to configure an interface, a new interface. Okay, you can reuse the on the put request on Postman. The put request you can reuse on body the raw. You can reuse this. Copy at the end. And down here, paste. But this should be a variable yang config. Okay, yang C uppercase config space equal space. IETF Interfaces column interface. Name loopback, in my case 888. Description new loop. Type IANA if type software loopback. Okay, in this case the enable should be true T uppercase. Okay, for Python should be T uppercase. Be careful with loopback. Okay, no space, L uppercase, true T uppercase. Software loopback, L uppercase. Different IP address, 88888888. Use any subnet mask. And that's it. Review the code. Should look like this. Okay, be sure the IP is different than existing loopback interfaces. Okay, save. Create a variable to send the request and store the JSON response. Use the variables created in the previous step as parameters for the request put method. This method sends an HTTP put request to the RESTCONF API. Assign the results to the request to a variable named resp. The variable will hold the JSON response from the API. If the request is successful, the JSON will contain the return yang data model. Before entering statements, please note that the variable specification should be on only one line in your script. Enter the following statements. This variable specification should be on one line in your script. Okay, the response, request put, the URL, the data, authentication headers, and verify false. Okay, on the previous file, get file, copy this. Go to the put file, enter, paste. But it's not get, it's put. Resp put API URL and add the data. The data you will put the format JSON dumps. That dumps. And add this variable, the yang config variable. Don't forget comma. Authentication, the username and password, the headers configured previously, and verify SSL certificates false. Save. Enter the code below to handle the response. If the response is one of the HTTP success messages, the first message will be printed. Any other code value is considered an error. The response code and error message will be printed in the event that an error has been detected. Okay, add this. Enter. If res that status code underscore code is greater this this character man ASCII this character is greater or equal than 200 and response code status is lower than 299 column enter print status okay column the variable format response status code. Okay, enter. Backspace else column enter print error that status code enter backspace and review. If the response status code is greater or equal than 200 and response status code is lower or equal than 299 column print status okay print the variable and format show the variable response status code else should be an error the variable line break the error message show the status code and the JSON response. The table below lists the various elements of these statements. Response, the variable that holds the response from the API. Request put, the method that makes the put request. API URL, the variable that holds the URL address string. Data, the data to be sent to the API endpoint, which is format is JSON. Authentication, the tuple variable created to hold the authentication information. Headers, a parameter that is assigned the headers variable. Verify false, a parameter that disables verification of SSL certificate when the request is made. Response status code, the HTTP status code in the API put request replay. Save and run the script to send the put request to the CSR1 KB. You should get a 201 status created message. If not, check your code and the configuration for the CSR1 KB. You can verify that the interface was created by entering show IP interface brief on the CSR1 KB. Okay, and verify the codes. This put file, the libraries, the modules, disable SSL warnings, API URL for a specific interface, in my case, interface equal loopback 888. The headers, accept and content type, application yang data plus JSON. The username and password. This is the data to create the Yang language with on JSON format. To create the new loopback, in my case, the loopback is loopback 888 with this IP address and subnet mask. Verify do not match an existing IP address. The method put the URL, the data, basic authentication, the headers, verify false. Okay, and show the status. Save. Okay, and run the script. With Python 3 RESTCONF put .py, enter. The status okay, 204. Okay, go to SSH connection, enter. Okay, enter, Ctrl C, enter. Okay, very nice. But look at this. Previously, loopback 888 was created. Okay, another student created this loopback 888. So that's why the status okay is not 201. It's not created, it's modified. So the status is a different number than 201. Okay, anyway, review. SSH developer and name, the password. Show IP interface brief. Look at loopback 8888. This IP 888888. Very nice. The method is other. Is Yang using RESTCONF. And also you can verify using the previous get information and run this again, the previous get file, Python 3 RESTCONF get, enter. And now you can see Loopback 888, IP address and subnet mask. Okay, very good. Thank you very much.